So in order to calculate the residual, we've already worked out if there's a linear correlation by checking for the value of the PMCC, using that to find a regression line, and now we're comparing the values to the regression line. So there's two ways we can do this, one using the maths mode, there's another using the table mode. I need to memorize that the residual is calculated by doing the actual value subtract the predicted value. If my actual value was bigger than expected, it's going to come out positive. If my actual value was smaller than expected, it's going to come out as negative. So I'm going to break this question down into two parts. I'm going to calculate the predicted first, and then I'm going to do the subtraction to calculate the residual. So I've got this list of data, and I've added an extra column to it so that I can work out each of these predicted values. I've already got the actual and the x variables. So using the equation of the regression line and going into maths mode, I can put in the value of 21 and get out the predicted value. Okay, but I need to think, is that going to be accurate? Well, actually, I can put in the 62 as well to give me another number, and then put in the 30. That's using the math mode, and if I keep putting in the next values, 20, 35, 57, I can fill in that column using maths mode. Like I was saying about keeping it accurate, at the moment, this isn't going to be as fully accurate as it could be, because I've used the rounded values instead of the full values given. So there's going to be some errors in this. Method 2 is to use table mode. If I go into menu 7, which is table mode, I can put in the equation of the regression line here. That gives me, it's got an X on the end of it there as well that you can't see, but that gives me the equation, and if I press EXE, it brings up a list of values here, 1, 2, 3, 4. If X was 1, if they had one item to pack, it would take 170 minutes. If they had 2 items to pack, it would take 174 minutes. Depending on the settings on the calculator, it might show a change column as well. This is increasing by 4.61 each time. We knew that already. I'm not interested in 1, 2, 3, 4. I want to know how much it is for 21, 62, 30, 20. So what I've done is I've typed in the values that I want, and that's bringing back the predicted values for 21. So that was Maria's first job that she did there, 21 items, predicted to take 262.45 minutes. Just need to keep repeating that, putting in the values that you want. I can either put them in one at a time in the first row and write down my answer, or I can put them all in a long list and write them all down. Whether you've used method 1 or method 2, using the math mode or the table mode, this is what my table of predicted values looks like. And most of the numbers are fairly close. 350, 387, difference of about 30 there, difference about 40. Okay, so comparing them, they seem close together, but how much are they different? And that's what the residual is asking for. So the residual is the actual value minus the predicted. So I need to do 270 subtract 262.45, 7.55. Okay, so in this one, Maria took 7.55 minutes longer than predicted. In this one, 420, subtract 451.71. Well, Maria was 31.71 minutes quicker than expected, comparing that actual with the predicted. And if I carry on through that, I can calculate all of those residuals. Some people are working quicker, some people are taking longer than the expected. Remember, the regression line is just a model. It's not actually going to mean that everybody takes exactly that time every time. So that was the key steps for finding the values of the residuals. And I've started to spot on some patterns. Where are these negative numbers? Mario, Betty. Mario's got a negative. We're looking for big numbers. Alice has got a big number, 56 there. So let's see if we can see any patterns in how these people are performing compared to expected. And this is what part F is talking about, finding the mean of the residuals. So all of Betty's residuals are there. All 3 of her times were negative. So she was quicker than the regression line in all 3 of those packages that she completed. On average, 41 minutes quicker than expected. What about for Alice? Well, she's got 3 numbers, each about 50, 47, 49, 56. In total, her residual, the mean of her residuals is 51 minutes. She's taken 51 minutes longer than expected to complete the tasks. So using these residuals, we can now make a better estimate for Betty and Alice. We know that Betty's a quicker worker. We know that Alice is a slower worker. So if we ask them each to pack 45 items, can we just say it would be this 37,373? Well, actually, on average, Betty is 41 minutes quicker, so it might take her 331.9 minutes. On average, Alice is 51 minutes slower, so it might take her 424.5 minutes.